Hello and welcome to this release webinar of the Anybus CompactCom CC-Link IE for TSN, time-sensitive networking. My name is Thomas Karlsson and I have a couple of Anybus experts with me here who I introduce shortly. But before that, we have some technical expertise from our Anybus team with us today. So if you have any questions during the webinar here, feel free to use the chat function and we'll try to answer that as we go. But today we're going to talk about this fellow here, the Anybus CompactCom CC-Link IE for TSN, time-sensitive networking. TSN has been a hot topic for more than 10 years since the idea was first incepted. But now it's coming to the market. What does it mean to users? How has Anybus implemented this into the Anybus CompactCom? And what are the future prospects that we're going to talk about today? And with me, I have Joachim Wiberg, Head of Technology at the HMS Anybus team, and we have Samuel Alexandersson, Business Line Director for the Anybus Embedded team. Welcome, guys.
Thank you.
So first, Joachim, give us a recap here. What is TSN?
TSN is really a set of standards that's being developed by IEEE that standardize Ethernet. That's actually used on communication between computers as well. And since it's being a standards development by an open organization, it's a good foundation to make sure that it's something that will be used and standardized and can be used by almost any company that would like to use it. But Ethernet and TSN on Ethernet is basically, that's just the layer to transport data on the lower layers. On top of TSN, you actually need an application protocol that we've seen from before, for example, Ethernet IP and Profinet, or CCLink, or OPC UA, that makes the data valuable. It defines how the data is transported through larger networks. So TSN is just the lower layers of a network. There needs to be something on top of that.
Right. How is TSN being standardized?
Yeah, as I said before, it's being developed by IEEE that develops and standardizes regular Ethernet. So they several years ago created a task group called TSN Task Group to actually add and expand on what Ethernet provided today. So they had the topic of looking into how to provide time awareness and real-time constraints on regular Ethernet. And this is done by adding several smaller pieces to regular Ethernet, small parts of the standard that's being added. And that's being used by different industries. Initially, it was targeted movie theaters where they need real-time performance for high-quality video and audio. It's also being used in cars for infotainment system. And at the same time, industrial automation companies realized that this is something that we also would like to use, since real-time automation or real-time communication and time awareness is key for industrial automation as well. Mm-hmm. So they realized that, hey, standard Ethernet providing those key functionality that we also need. So they jumped onto that and started looking, how can we use this? But since several different industries are using it, they pick and choose from those smaller standards. Right. And defines profile on top of TSN, saying that those are 4, 5, 6, 7 different standards that we need from TSN to realize our application needs.
Okay, thanks for that background. If we get a little bit more technical, TSN allows all TSN devices to communicate very quickly, down to 1 microsecond compared to the Grandmaster clock. But if I understand it correctly, it's not really the speed that's the revolution here. It's more how we standardize the Ethernet framework. What can users do with TSN that they couldn't do before?
As you say, it's often talked about the sheer performance that TSN provides and bring to the network. I don't think that's the larger piece of new functionality that TSN actually brings. What TSN brings is it allows you to run different types of traffic on the same network, on the same wire at the same time. So this is often named as converged OT IT traffic. But basically, simply put, you have the control traffic provided by Profinet or Ethernet IP, for example, on the same wire where you grab diagnostic data using some information protocol similar to OPC UA or something like that. You could also have a ongoing video stream from one part of a factory floor where they take motion pictures of a core process that's being brought up over the same network to a high performance computing platform in the IT system, where we do some AI analysis of what's going on the factory floor. And everything this shares the same network. In order to achieve this, the network needs to be commissioned, obviously, making sure that the traffic doesn't disturb each other. So basically what you do, you set up the system, configure the system and say, this is the amount of time I need for my control traffic, and this is the amount of time I need to do diagnostic. And maybe the rest you just leave open, and that's what you can use for the video stream.
Right, okay.
And the same thing is actually used, the same type of commissioning is actually used to be able to run 5G on the factory floor. TSN will be one of the key features, I think, to make 5G on private networks a valuable piece of technology for industrial communication moving forward.
Right. 5G is also an enabler, of course, of this the speed in the future.
Correct.
So the one part of the network is always set aside for this business critical process communication. Yes. Yeah. Okay. You've been working with industrial communication for a long time. What would you say are the low-hanging fruits for TSN? What will we see as the first applications?
I think the first application that we will see is not those large converged networks that's being talked about that we see in the future. This is something that will happen for sure. What I think we will see instead is networks making use of TSN just for regular control traffic. Companies trying to move away from proprietary systems where it's extremely costly to develop ASICs or maintain FPGA constructions for a more or less proprietary network. So instead you can go and buy commercial off-the-shelf Ethernet chips from someone providing that. So this is what we've seen CCLink doing. They moved from CCLink IE field using a more or less proprietary technology, still open from CLPA, but now they build a foundation based on TSN, allowing anyone that can go out and buy TSN chips to build CCLink IE TSN. And that's actually what HMS has done. However, we developed a TSN construction by ourselves to make it integrate well in the CompactCom series that we have recently released here.
Right. Excellent. Thanks a lot for that background to the technology, Joachim. So Samuel, let's have a look at the actual products that we're releasing today. So we have one version with housing and one without. But the Anybus CompactCom is used in millions of industrial devices today. If we talk about it from a general point of view first, what problem does it solve?
Good question. Our main customers, they are device makers, companies that provide industrial products such as sensors, controllers, drives, etc. Their customers, they want to connect these products to their industrial networks to get data and collect valuable insights so that they can become more predictive and in the long run more productive and sustainable.
Right.
The challenge here is that it's very complicated to connect an industrial device to an industrial network. And here our products come into play. The Anybus CompactCom can connect any industrial device to any industrial network. It's easy to work with, and it speeds up time to market for our customers since they don't have to spend time and resources on developing and maintaining network technology.
Right, because that can be a time-consuming process otherwise.
Yes, it's lots of hard work.
Yeah, right. And speaking of that, what makes this product different? What does this do compared to if you were to develop it yourself or choose another communication solution?
I think one of our main focus is making industrial network communication easy. We do everything we can to make this as easy as possible for our customers. So we are there throughout the InDesign journey. And also, once you have implemented one network, it's easy to implement to all the major networks in the industry, basically. And also, total cost of ownership. It's expensive to keep this updated. So if you want to focus on your core business, we are a good partner to go with.
Right. Yeah, because there's always more networks to connect to if you're expanding. Yeah.
Yes.
Yeah. So this is the first product, the first gigabit product for TSN out there. So why CC-Link? Why is this the first network to come on Anybus CompactCom?
CCLink has come a long way. They are at the forefront of this technology. They have products available, and they have motivated customers working on this. And this is important for us. We are on this very early, which comes with lots of uncertainties. So we need to have companies to work with, to learn more, and to learn how these products can be used. So in order to succeed with this, motivated companies are key, basically, I would say.
Right. And that's already there in the CC-Link world. Yeah.
Yes.
How can companies use this first version of Anybus CompactCom for CC-Link IE TSN?
We wanted to be quick on the market, so it comes with just enough functionality for our customers to connect to TSN networks and get processed data. But to start using it, it's basically to buy the brick or the module, follow the instructions, read the manual, and you're ready to go.
Right, easy peasy. Right, so if we look a little bit into the crystal ball here, so CC-Link is first. What about other industrial Ethernet protocols going forward?
Earlier this year, we developed a proof of concept for Profinet on TSN, and that has gained interest, so we are continuing exploring that. For other networks, we are in tight dialogue with customers, companies, and network organizations to learn and understand when these will be available on the market. So keep your eyes open.
Right, absolutely. So finishing off here, what if we look further into the crystal ball, maybe 5-10 years ahead? What do you see TSN being in the nearest future, and maybe a little bit further ahead, Joachim? What do you say?
I think for 1 to 5 years, I think we'll just see a gradual expansion of TSN. I think it will take years until we see a larger use of TSN-based networks out there. Starting from 5 years and forward, I think we will see more and more installations of that. And over time, I'm rather sure that we will see the majority of installations using a TSN-based network. But even though 10 years from now, I'm sure that we will still see regular Ethernet, be regular Profinet being installed in factory floors as well. So I don't think there will be a completely new market where everything is on TSN in the last coming 5 to 10 years. But after that, I think the TSN-based networks will be the general go-to guy when you install something new.
Right. Yeah, so it's still a conservative business. It takes some time for technologies to get adopted, but TSN is definitely a coming technology. Okay, Joachim and Samuel, thanks very much for being with us in this release webinar, and thanks very much for listening. If you want to know more about the Anybus CompactCom CC-Link or TSN, you can check out anybus.com or visit the HMS company website on hmsnetworks.com. Thanks very much for listening today.